This is the last section in Chapter 5. It's on solving radical equations and inequalities. And this is kind of a cute little joke. Your behavior reminds me of root 2. And the student's like, why? Because it's completely irrational. A couple vocabularies: radical equation, radical inequality. Radical equations is an equation that involves a variable under the radical. That's important. It's the variable under the radical. So if you just had like y equals the square root of x, root 2 times x, is there a variable underneath this radical? No, there's a number under the radical. This is not a radical equation. What is the parent graph? This is actually a line. This is linear. Instead, it's not radical. A radical one would be y equals the square root of 2x. That's a radical equation because there's an x underneath the radical. And then radical inequalities would have an inequality symbol such as that. Okay, we're going to start off with solving containing one radical. Kind of like with logarithms, you have to get the radical by itself. Like how with logarithms we had to get the logs by themselves. So we're going to get rid of the 2 first by dividing it. Bring down what's left. And then we need to undo the radical since it's over there by itself now. So first thing I should probably say is isolate the radical. That was the first thing I did. Then undo the radical by a square undoes a square root. So the second step is to undo the square root by squaring. So I'm going to square both sides. And then the squaring undoes the square root. The square root's gone. I think of it as lifting off like a roof. Think of this as the roof, and the square undoes it, gets rid of it, takes it away. 7 squared is 49, and then subtract 1 from both sides, and you get 48. And then you need to check these and make sure they work. So I'm checking in the original inequality, 48 plus 1, that's 49. The square root of 49 is 7. 7 times 2 is 14. 14 equals 14. We have a check. Okay, try this one on your own, and then I will do it. So again, we have to isolate the radical. We need to divide both sides by 5. Bring down the radical. We have 3 over there. We undo a cube root by cubing. So I'm on step 2 here. We undo cube root by cubing. And then the cube undoes the cube root. So you get rid of that whole radical. And you're left with 4x plus 3 equals 27. Then this is just basic algebra. Subtract the 3 from both sides. Divide by 4. We get x equals 6. We plug that back in and check. So I'm going to have 5 to the cube root of 4 times 6 plus 3. So that's 24 plus 3 is 27. The cube root of 27 is 3. 5 times 3 is 15. And that does equal 15. So we have a check on that one as well. Letter 1b and 1c are very similar to the 2 I just did. So do those on your own, and then I'll give you the answers. Let's do number 1a together real quick. So this is again, we need to isolate the radical. So this time we have a 4 being added. We undo addition by subtracting. 5 minus 4 is 1. We undo the radical by squaring both sides. So that's going to be x minus 1 equals 1. Add the 1 to both sides, x equals 2. Check. 4 plus the square root of 2 minus 1. 2 minus 1 is 1. The square root of 1 is 1. 4 plus 1 is 5. It checks. And then these other 2, I'm just going to hopefully find the answers here. Do I have them? I might have to look them up in the book. That way I'll save your time by not working through them all. So 1b, you should have gotten 4. And 1c is 39. Now, second type of problem. We have radicals on both sides. So, as long as you have one radical equals another radical, as opposed to a radical equals the sum of radicals, this is harder here. We're not going to do that right now at least. So, we're not doing that. We've just got a radical equal to a radical. And we do have a 5 sitting there. There's nowhere else for this 5 to go. You could divide both sides by 5, but then you'd have a fraction over there. You'd still have a coefficient out there. So you just leave it, and then you're going to square both sides is what you're going to do. So square both sides. Because what you do to one side, you have to do to the other. So this side will get squared. This entire, the entire side gets squared, everything. So squaring undoes the square root. I have 35x equals, when I square this, I'm squaring each of these individually because you have a product of 5 times the square root. So you're going to square the 5 times, and then you're going to square the square root, which gets rid of it. So you have x plus 2 left. You have to put that x plus 2 in parentheses because it's still, that whole thing is being multiplied to that 25. That means on the next step, I need to distribute my 25, and then I can get combine my like terms, subtract my 25 across. I'm doing that in my head. By now I'm hoping we are comfortable doing some of these steps in our head. Divide both sides by 10, x is 5. You have to check. So plug that back in. Square root of 35 times 5, does that equal 5 times the square root of 5 plus 2? This side's easier to do. Actually, this side isn't too bad. If I wanted to do this without a calculator, I could do that because 35 is 7 times 5. And then I have this extra 5 here. I'm taking the square root. That simplifies to 5 root 7. And then over here, I've also got 5 root 7. So it checks. I didn't even need a calculator to do that. Okay, these two you can try on your own. The first one is very similar to the one I just did, so I'm just going to give you the answer to that one. I have to find it here in my book. Okay, that is 6. And this other one, because it's a cube root, again, try it on your own because I'm confident you can do it, but I'll work through it real quickly too, just for fun. So on this one, we've got a radical equals a radical. We have a cube root, so I have to cube both sides. Cube undoes cube root. I'm left with x plus 6. I have to cube my 2. 2 to the third is 8. And then this will undo, but the x minus 1 has to go in parentheses. So that's going to be x plus 6 equals 8x minus 8, because I have to distribute. I need to get my x's on the same side. I'm going to subtract x and get it over here. I'm going to add my 8 and get 14 over here. I'm going to divide both sides by 7 and get 2. And I need to check. Cube root of 2 plus 6, that's cube root of 8, that's going to be 2. And then over here I have 2 times the cube root of 2 minus 1, which is 1. 1. Cube root of 1 is 1. 1 times 2 is 2. It checks. Okay, new type of problem. We have a square root on one side and, some on the other. So, same deal. We've got the cube, or the square root rather, it's isolated, so we can go ahead and square both sides just like we've been doing. So it's the same beginning step. The square undoes the square root. I'm left with just x plus 18 equals, and I have to square x minus 2. Remember, that means you have to FOIL it out. You have to distribute it because you're multiplying it to itself. So that becomes x squared minus 2x minus 2x. I could write those out if you want. And then negative 2 times negative 2 is positive 4. Negative 2x minus 2x is minus 4x, and then plus 4. I hope I'm not going too fast. I'm trying to go at a fair clip just so that you don't have this huge long video to worry about. So I've got that all FOILed out. I'm looking at this. I notice I've got an x squared. That means this is a quadratic. The way to solve a quadratic is to get everything on one side and set it equal to 0. I want my x squared to be positive, so I'm going to leave it right where it's at, and I'm going to move these other terms over. So this will end up being a 0. I'm going to be subtracting x from both sides, so I'm going to have minus 5x. I'm going to be subtracting 18 from both sides, so I'm going to have negative 14 over there. And now I'm going to factor this, because I can see that it will factor. 2 sets of parentheses, x, negative 7 and positive 2. Then that means that x is 7 and negative 2 when I set those each equal to 0 and solve in my head. Okay, we have to check. So we have to check both of these, by the way. So I need to plug 7 in. 7 plus 18, that's 25. Root 25 is 5. On the other side, I'm plugging in 7 minus 2. That does equal 5. 7 checks. Okay, negative 2. Square root of negative 2 plus 18. Does that equal negative 2 minus 2? Negative 2 plus 18 is 16. Square root of 16 is 4 equals negative 4. No, not true. So that means that negative 2 is an extraneous solution. It does not work. I do want to see all this work, and then you could just put an X through the negative 2. It shows me that you found it, but then you checked it as well. So don't totally annihilate it. I like to see that you actually found it, because it shows me that you did all the algebra correctly. But your final answer, if this was on a test and you had an answer slot, you would write x equals 7 in the answer blank, like if this was question number 1. You don't write down the negative 2 as your answer. But I do want to see it in your work. So these are the same types of problems. There's 2 of them. And do them on your own, and then I will give you the answers. And I can't ask you if you want me to work through them for you or not. Maybe I'll work through the second one. I'll just give you the answer to the first one. So the first one is 1. So I'm guessing that probably when you solved this, you got 2 x's and one of them didn't check. And x equals 1 was the one that did. And then I'll go ahead and do number 3b. I'll do it fairly quickly since you've had a time to work it on your own. So we're going to square both sides. Negative 9x plus 28 will equal, I'm going to FOIL this out. Well, I guess I'll do it by hand. I was going to do it in my head. Anyway, that's going to be x squared. That's going to be minus 4x. Minus 4x is minus 8x. 4 times 4 is 16. Okay, we're going to move everything over to the right, so this will become a 0. I'm going to be adding my, so the x squared is here. I'm going to be adding my 9x, so that's going to be 1x. I'm going to be subtracting my 28, that's going to be negative 8 and 4 is 12. And that'll factor pretty nicely. That's going to be positive 4 and negative 3. So that means my solutions are negative 4 and positive 3. We have to check them. So we'll plug negative 4 in. Negative 4 times negative 9 is 36 plus 28. Let's see, that's 14, that's 64, that's 8. And I have to check negative 4 on the other side as well. Negative 4 plus 4. Oh, no. My bad. No, that's not right. Okay, negative x. X is negative 4. Plus 4, so that's positive 4 plus 4, that's 8, it checks. So this is a go, that one works. Now I'll plug 3 in over here. Negative 9 times 3 plus 28, does that equal negative 3 plus 4? That's negative 27 plus 28 is positive 1. That's also, oh look at this, they both check this time. So they both work. Okay, next type of problem. We are solving, this time though, instead of using radical notation, we have it written with rational exponent notation. And you have choices. You could switch this into radical form. In fact, the book maybe does that, I can't remember. But I prefer to solve it by leaving these just exactly the way they are, because you can undo them just exactly how they're written. So if I want to get rid of something raised to the 1/5, I can raise the whole thing to the reciprocal, which the reciprocal of 1/5 is 5. And what I do to one side, I have to do to the other. I'm going to do that right away because I don't want to forget to do that. But let me explain why this works. Because remember, if you're raising a power to a power, you multiply these together. And when you do 1/5 times 5, you get 1, which means now the power is gone because you don't have to write 3x minus 1 to the 1, it's just 3x minus 1. And then 2 to the 5th is 32. And then you can do simple algebra, add 1 to both sides, so we get 33. Divide by 3, we get 11. And we do have to check it. So we're going to check. 3 times 11 is 33. 33 minus 1 is 32. The 5th root of 32 is indeed 5. because, or not 5, 2. What am I thinking? I don't know what I'm thinking. That's not right. It's 2. 2 to the 5th is 32. And then, so it checks, because that's 2. Okay, this one, I'll go ahead and do it. You could try it on your own, but I'll go ahead and do it. Because we have an x over here, it's a little bit different. Last time we had a constant over here. We can still do the same thing, though. If we want to undo something raised to the 1/2, and it's all isolated, by the way, there's nothing else over here, we would undo it by raising it to the reciprocal, which in this case is 2, so we have to raise the other side to 2 as well. So bring down the x squared, and then this 1/2 to the 2 is gone, so you just are left with x plus 12, because that's 1/2 times 2 is 1. And then I see I have a quadratic, which means I need to move everything over to the side with the x squared, and I'm going to be factoring again. And this time it's -4 and +3. So that means my answers are 2. I have two answers, 4 and -3. I have to check them both. So we were left with, here I'll just write the original. So I need to plug in 4. So 4 equals, parenthesis, 4 plus 12 to the 1/2. We're checking to see if that's true. 4 plus 12 is 16. 16 to the 1/2 is the same as the square root of 16, which is 4. So 4 does equal 4. That's a check. Now we'll plug in -3. -3, does that equal -3 plus 12 to the 1/2? So bring down the -3. This is 9. 9 to the 1/2 is the square root of 9, which is 3. Oh, we have a problem here. That is not true. So that means this one does not work. So see how you really have to check, because sometimes you get extraneous solutions, and you maybe we don't really know when we're going to get them sometimes. Oh, and then this just says exactly what I was saying. Okay, do these 3 on your own, and I will give you the answers. Make sure you check them all, because as you saw on the previous examples, we did get some extraneous solutions. So I think what I'll do, maybe I'll give you the answers to A and B, and then I'll actually do letters for C. So let me look up the answers here in the book. 4A is 22. 4B is 5. Let me see, I might have worked these ahead of time at some point. Yeah, 4A, when you solved that, you only ended up with one answer, so you didn't have any extraneous ones. 4B, when you worked that, you should have gotten 5 and -3, but -3 doesn't work. So 5 is the remaining answer. And then I'll do 4C, just for fun. So what I would do on this one, I would divide this 3 over, because I noticed that 9 divided by 3 can be done. So I have x plus 6 to the 1/2, and that's 3. I raised the reciprocal, which is 2. I do that to both sides. That knocks that out of there. X plus 6 equals 3 squared, which is 9. I subtract 6 from both sides. Aren't these fun? Oh gosh, look at that bad mistake. Okay, -6. 3. These are so much fun. There's just so, I love it. 3. So plug 3 back in to check. 3 times 3 plus 6 to the 1/2. Does that equal 9? 3 plus 6 is 9. Square root of 9 is 3. 3 times 3 is 9. It works. Yahoo! There's your answer. Great. We're clickety-clacking right along here. On to, and I can't even see what this is. It must be example 5. So the next type of problem, it says to use a calculator and to do it algebraically. Well, I like doing things algebraically, so I'm going to do it algebraically first, because that's more fun than doing a calculator, but we need to know how to do it both ways. So, you have an inequality. Anytime you have inequalities, you have to be careful. When we were solving quadratic inequalities, we had to use a number line. When we were solving rational inequalities, we had to have a number line. When we're solving radical inequalities, we need to use a number line. The way we get our critical number, I'll call the critical numbers. Those are the numbers that go on the number line. There's 2 ways. You have to, just like with the rational ones, you had to solve it and get one of your critical number that way, and then you had to put the denominator equal to 0 to get the other critical number. Well, with radicals, first you just solve it in the usual way by making the inequality an equal sign. But secondly, you have to set the part underneath the radical equal to 0. So you have to make 2x plus 4 equal to 0 and solve. So those are the two places where you look for your critical numbers. So let's go ahead and do it. First, I'm going to be just solving in the usual way by making the inequality an equal sign and solving to see what we get. So I have square root. I have to square to undo. So I've got 2x plus 4 left equals 16. Subtract 4 from both sides, divide by 2. Let's check that and make sure that works. Let's plug 6 in here. 2 times 6 is 12. 12 plus 4 is 16. The square root of 16 is 4. 4 equals 4. So it checks. But there is another critical number, and that's where 2x plus 4 equals 0. So the part under the radical, whatever's under the radical, you need to make that equal to 0. So I'm going to subtract 4 from both sides. I'm going to divide by 2. That's my other critical number. I go to my number line, put the smallest one on the left, the larger one on the right. So these two numbers divide the number line into 3 intervals. And then we choose a number in each interval and check it in the original inequality. So a number smaller than -2, let's try -3. I want to know, is that less than or equal to 4? So, we're going to have 2 times -3, which is -6. -6 plus 4 is -2. That doesn't even exist, does it? So, any number less than -2, is it even going to work? It's not even going to exist, so it's undefined here. If it's undefined in that region, in that interval, you're not going to have a solution. Okay, let's try between -2 and 6, we can use 0. 2 times 0 plus 4. Is that less than or equal to 4? That's square root of 4, which is 2. There's 2, yes, that's less than or equal to 4. That's true. So in this interval, we are getting some true solutions. And then let's pick a number bigger than 6, so let's use 7. 2 times 7 plus 4, is that less than or equal to 4? So that's 14 plus 4, which is 18. The square root of 18 has to be bigger than 4 because the square root of 16 is 4. So a bigger number than 4 is not going to be less than or equal to 4. So that's going to be false. So the only true interval is from -2 to 6. And you want to check and see, like to decide whether it's a parenthesis or a bracket. If you do have an equal to here, so it's probably a bracket, but just check and make sure if you plug -2 in here, that's going to be 0, because that'd be -4 plus 4, which is 0. And 0 is less than or equal to 4. So that's not undefined. So it's going to be a square bracket because of this equal to. And then 6 will be a square bracket as well. So the answer is the interval from -2 to 6. So now let's go ahead and do this with a calculator, because it did ask us to do that, and plus I want you to know how to do that anyway. On y equals clear. So we'll simply plug in the square root, second square root of 2x plus 4, close, and then in y2 we'll put in 4. We'll do zoom 6 for a standard window. And we're looking for where the radical is less than or equal to the line. So here's the line. I want to know where the radical is underneath. Well, the radical just starts here at -2, doesn't it? So you can't say from -infinity, because it only starts here. So from -2 up to where they cross. 1, 2, 3, 4, 5, 6. Of course, we know it's 6 because we did it here. You can also do second trace, intersect, enter, 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 and see that it is at 6. So on this interval here, from -2 to 6 is where the curve, the radical, is underneath the line. And remember, we answer in terms of the x's. The x's are from -2 to 6. Okay, these are for you to do on your own. I kind of think I might do one, though, with you, because these are a little harder. So I think I'll go ahead and do this one with you on the left here. So To solve this, we're going to solve it in the usual way to get our critical number. Oh, let's just make that an equals. So I have to isolate my radical. I need to move my 2 over by subtracting it. So I'm going to have 3 over there. I square both sides, so I get x minus 3 equals 3 squared, which is 9. Add 3, I get 12. I'm going to do a quick check. 12 that's 9 is 3 squared of 3 is 3. 3 plus 2 is 5. Okay. Then, that's the first critical number. But remember, whatever's under the radical, in this case x minus 3, you have to make that equal to 0 as well and get another critical number, in this case 3. So these are our 2 critical numbers that are going to go on our number line. Put the smaller one to the left, the bigger one to the right. And then we have to check each number in there. So I'm going to use 0 for this interval. Okay, if I plug 0 in here, I'm going to get negative 3. I can't take the square root of negative 3. So this is an undefined interval. The radical doesn't even exist over there. Now a number between 3 and 12, I'm going to choose 4. So if I plug in 4, 4 minus 3 is 1. The square root of 1 is 1. 1 plus 2 is 3. 3 is less than or equal to 5. That is true. Then a number bigger than 12, I want to choose wisely. I want to do one that I can take the square root of. I can take the square root of 16, so that would mean that this would have to be 19. So let's choose 19. 19 minus 3 is 16. The square root of 16 is 4. 4 plus 2 is 5. 5 is less than or equal to 5. That's true. Oh, that's interesting. Huh. So those are both true. I'm thinking 25. Let's try another one. That just doesn't seem right. Did I make a mistake? I'm going to try a bigger one. Let's try 25. 26. Let's try 28, because 28's in this interval. 28 minus 3 is 25. The square root of 25 is 5. Oh, yeah. The square root of 25 is 5. 5 plus 2 is 7. 7 is not less than or equal to 5. That's false. What did I do with this? Okay, I think this is supposed to be false. I tried 16. 16 is bigger than 12. I'm a little curious if I made a mistake here. Let me try 16 again. This is 16 minus 3. That's a question. Oh, that's 13. Yeah, what was I thinking? I have no idea what I was thinking. Oh, 19. Yeah, I wanted to use 19. Sorry. 19 minus 3, because 19 is in this interval. That's 16. The square root of 16 is 4. Oh, 4. 5, 6. 6 is less than or equal to 5. False. Okay. I was going to say, that just didn't make sense. All right, I'm liking this better. So again, I have a true interval between 3 and 12, and it's a less than or equal to, so these are going to be square brackets. So it's going to be from 3 to 12 inclusive. Let's check it on the calculator. This is a long lesson. I am trying to go as fast as I can. So I'm going to have the square root of x minus 3 plus 2 in y1, and then in y2 I'm going to put 5. I'm going to graph it. Oh, they don't cross, so I need to make my x's bigger. Whoops, I went too far. Let's make it 20 and see what happens. Okay. I'm looking for where the radical curve is below the line. So again, that's here. And then we know that it's going to be from 3, and we know that that's 12 because we figured it out before. So this confirms that it's below in this interval. Oh, let me go back one and tell you the answer to 5b without working through it. So 5b is x is greater than or equal to negative 1. Or if in interval notation, that'd be negative 1 to infinity. All right, this is the last example. Yay, we're almost done. And this one's pretty easy too. It's just pretty much using a formula. You've probably heard that if when you're driving fairly fast and you hit the brakes, you skid quite a ways before you stop. And that's what this is dealing with. So the speed s in miles per hour that a car is traveling when it goes into a skid can be estimated using this formula. S equals the square root of 30 fd. So s is the speed. F is the coefficient of friction, so that's a coefficient. And D is the length of the skid marks. Length of the marks in feet. After an accident, a driver claims to have been traveling the speed limit of 45 miles an hour. So we'll put 45 in here for S. And the coefficient of friction was 0.7. So they probably figured that out from the road surface and the weather, if it's raining or not, and for it's icy, it has a different coefficient. And is the driver telling the truth about his speed? Oh, and the thing is, you have to look up here too, because you have to look at the length of the skid marks. So the policeman measured them, and they're 120 feet. Probably should check and make sure you got all the units correct, because D is in feet, so that's good, and S is in miles per hour, so we're good there too. So basically we're looking to see, is this true? So I'm going to go to my calculator and put this in. We're going to do 30 times 0.7 times 120 and get an answer, and then I'm going to take the square root of that answer. And I get 50. So the person was really going actually slightly over 50, wasn't it? It was 50.2 basically miles per hour according to the skid marks. Oh, so they're lying. Lying. Is that how you spell lying? I think so. Lying because the formula says they're going 50.2 miles per hour. And there's our little warm up for next time. So there we go. Last section in this chapter.